Hello everyone, this is Greg from ChemCore. In this video, we're going to be going over the naming, alkyl halides, and alcohols video. If you haven't had the chance to do this worksheet, it's available for free in the description below, as well as the answer key that we're later going to develop. And if you haven't had the chance to watch the actual instructional video, that's also going to be in the description below, available for absolutely free. It's only a couple minutes, makes it might be worth it just to go over some of the conceptual ideas that we're going to be using for this worksheet. Now, naming things generally follows the ideas of IUPAC naming, but in this case, we kind of shift some of the priorities of certain groups. And I always say that alcohols have number one priority, your halides are like a little under them, and then these priorities will later shift once more further, maybe in a couple chapters and more in Orgo 2 usually, where we start talking about some of the other functional groups. But other than that, the general ideas of IUPAC naming that I always teach you guys stays the same. My checklist is always find the parent chain, identify the parent chain, identify the substituents, number, and then put the whole name together. So we can follow that general rule for these compounds as well. I'm trying to show you guys that no matter how difficult Orgo gets, it's kind of the same pattern over and over and over again. Get good at the pattern, and you get good at everything else. So in the first problem, we have this really long compound. I mean, the parent chain is going to be the same chain no matter what, so let's just count from left to right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I count 10 carbons. And I know this has to be the parent chain. So we're going to name this. We know that it's a bit too big, that the parent chain name is decane. And now it depends, okay, where do we number from? Is it from left to right or right to left? We'll realize that on one end we have a hydroxyl group or an alcohol, and on the other end we have a fluoride or fluorine, an alkyl halide. Now, which one of these gets priorities? Remember that alcohols get priorities. If given the opportunity, you will always give the OH the priority in numbering. Sometimes no matter which way you go, it ends up having the same number. So just so you guys know, but in this case, we absolutely can start numbering from right to left in order to give the hydroxyl the number one position. Okay, so if we give this the number one position, you keep numbering along the chain, we'll eventually figure out that fluorine is the number 10. So remember that one weird thing about alcohols is that we don't have like a 1-methyl or a substituent name as we usually would. In this case, we kind of change the actual parent chain. So what I would do is I would actually go back, and I'm going to change the original parent chain that we wrote down. And I'm actually going to name this 1-decanol. That's our parent chain now. I like to write it down and forget about it so we never have to worry about it again. And we're not going to confuse ourselves. And the only other substituent that we have here is 10-fluoro. And so if we put this all together, our final name is 10-fluoro, 1-decanol. And this name would include our fluorine substituent on the number 10 position, our parent chain, which is decane, and that hydroxyl on the number 1 position. In question 2, we're asked what class of compound is 2,7-dichlorooctane. I want you guys to realize and start getting used to seeing these substituents and being able to identify and start categorizing molecules in your head. And I feel like these questions are pretty useful. They're easy, hopefully. And some of you might think that they're too easy, but it helps you just to see a molecule and to start your gears working to be able to solve a future problem. And so this is going to be an alkyl halide. Question 3, what is the most correct name for this compound shown in this diagram? Again, we're asked for an IUPAC name. Let's find the parent chain. There's only one chain possible, so 1, 2, 3, 4, 5, 6, 7. So we have 7 carbons, meaning that our parent chain name should be heptane. And now our question is, from which direction do we name? This is going to be an alkyl halide or a dialkyl halide because there's 2 halogens. But to give them the overall number, I hope it's very visible that we should probably start naming from the right side. In this case, this fluorine gets number 2, and this other fluorine gets a number 3. And so we can name our substituents the same way that we've been naming our hydrocarbons is 2,3-difluoro. Again, nothing changes. It's the same thing over and over again with like a little bit of quirks. And that's really all Orgo is. You learn some old rules And then every time you get to something new, it's the same thing with some extra quirks. That's really all it is. Heptane. The next problem, again, another IUPAC name. Let's find the parent chain. So this is the only parent chain available. This is 3, 4, 5. So we have pentane is our parent chain. And realize that these two substituents are right in the middle. So no matter where you number from, it's going to end up giving the same number. And so both of these substituents are in the number 3 position, meaning that we have 3,3-dibromo. And so if we put it all together, it's 3,3-dibromo pentane. And number 5, what class of compound is shown in the diagram below? Let's call this a hydrocarbon, right? I only see hydrogens and carbons. But let's be a little more specific in calling it an alkane, because I only see single bonds between the carbons, right? So we can be a little more specific and call it an alkane. Number 6, what is the most correct name? Again, another IUPAC name. Let's begin with finding a parent chain, and this question is going to be a little trickier. So it looks like it's maybe this one, 1, 2, 3, 4, 5, 6, 7. But here's the issue that a lot of students come up with. What if we name the parent chain like this? Right? 1, 2, 3, 4, 5, 6, 7. Still 7 carbons, right? The problem is that your hydroxyl, right over here, is not on the parent chain anymore. And so I like to bring up the situation. Imagine that you did use this parent chain, which I hope you guys realize is incorrect, but I like to teach this aspect just because it makes you realize, oh, if you're forcing something in IUPAC names, you're probably doing it wrong. And so what you would be left with is this substituent, right? It looks like kind of a methyl oxygen. So if you think about, okay, methoxide, is that a substituent? Like, have you ever been able to hear of that as a, what are you going to name it? 2-methoxide heptane or whatever? Like, it doesn't make sense. It's not a substituent. And so if you're sort of like thinking, oh, hold on, that doesn't really make sense. It doesn't make sense. Like it's not, you're doing it wrong, and you need to reorganize yourself and reassess the situation. And so what really should be the parent chain is this, because we're including the hydroxide. The hydroxide is now a substituent. And if you think that this is a new rule, it's actually not. I hope you realize that in the original IUPAC video that I hope you guys have watched, if you haven't, it's available in the YouTube in the same unit as this, I said one of the rules between differentiating between parent chains, if they have the same number of carbons, is which parent chain has the most substituents. That's the parent chain that we choose. In the original one, we only had one substituent, but now we have the hydroxyl and the methyl. So this is the parent chain that we should be choosing. And so we can determine that our parent chain is heptane. Okay. You guys can try numbering it, but I think it's very obvious that we should start numbering from this side to give the hydroxyl the number 1 position. And the number 2 would go to the methane. So again, I literally like to, if I wrote with a pencil, I like to take my eraser, flip the pencil around, and start changing what I wrote. I'm going to change it into 1-heptanol. Okay. And if you wrote with a pen, cross it out and write this instead. And then you have 2-methyl. There's a method to my madness. Every checklist that I give you guys is kind of like something that I really want you guys to follow. You'll be getting the IUPAC correct every single time. In number 7, what class of compound is 3,6-dimethyl octan 3-ol? Looks like a really, really complicated problem, but realize once you see this ol, you can right away determine that it's an alcohol. Okay, this doesn't matter, yeah, whatever, it's carbons. I also want you to not be afraid of how they wrote this. If we go back to the previous problem, we wrote 2-methyl 1-heptanol. In reality, it is just as correct to start naming it 2-methyl heptan 1-ol. Just as correct. I actually like this method a little bit more because we start having a lot of, later in the course, we're going to start having a lot of different suffixes that we don't name as regular substituents, like alkenes and alkynes. And so having these kind of substituents helps organize everything together. And eventually, for now, if this is a little simpler and just makes a little more sense. But eventually, I think most people find this a little better. We're going to see that in a couple videos. Number 8, what class of compound is shown in the diagram below? This is, again, an alcohol. Now I know I just asked you guys to find the class of compound, but for your practice, you can go ahead and pause the video at this point and try to find the name of this compound. I think it's great practice. And if you were to find the name should be 6-methyl-4-decanol. Number 9, write the most correct name for the compound shown below. We have a multiple choice this time, but the way I like to solve short responses is I just like to find the name myself and match it to a possible answer. So first of all, let's find the parent chain. We have 1, 2, 3, 4, 5, 6, 7. That's the longest chain for sure. So we definitely have heptane. We can eliminate D. Heptane is our parent chain. I see a hydroxyl on the number 2 position, and these two methyls are going to be 3 and 4, meaning that we can actually go back and change this heptane to 2-heptanol, extra L, and then 3,4-dimethyl. And so if we were to choose a correct name, it should be 3,4-dimethyl-heptan-2-ol. In question 10, we're asked what class of compound is 1,5-dichlorohexane. I want you guys to see this chloro and realize that we're looking at an alkyl halide. Easy. 11, what class of compound is shown in the diagram below? I see this hydroxyl, this is an alcohol. And again, I know I just asked you to find the class of compound, but try to pause the video, try to figure out the name of the compound, and if you were to do it, you should get the name 3-methyl-3-nonenol. It's a mouthful, but you get the point. Number 12, what class of compound is 4-propyl-nonenol? Very similar to the previous problem, but I see this all, and I know it's an alcohol. And the next problem, what class of compound is shown in the diagram below? It's a hydroxyl. I instantly know it's an alcohol. And again, if you wanted to practice, you should try writing out the name of this compound, pause the video, and if you tried, you're coming back to this video, and if you want to see the answer, the correct name should be 5-ethyl-7-methyl-3-nonenol. Question 14, write the most correct name for the compound shown below. Let's follow our checklist. Let's find the parent chain, 1, 2, 3, 4, 5, 6, 7, 8. So we know it must be octane. And I'm not going to write the whole thing down because you guys see this hydroxyl. It's probably going to be on the number 2 position. So we can right away change it to 2-octanol. 1, 2, 3, 4. On the 4th position, we have a methyl. And on the 6th position, we have a methyl. And so we have 2 substituents, 4,6-dimethyl. And so the correct name for our compound should be C. Number 15, write the most correct name for the compound shown below. So let's find the parent chain, 1, 2, 3, 4, 5, 6, 7, 8. This is a great practice question. This is going to be octane. I'm just going to leave it like this because we know we're going to have to change the ending anyway. I want you to realize that, okay, if we were to name it from left to right or right to left, the number on the hydroxide would be different. And a lot of people would be like, okay, do I name from right to left because I'm supposed to give? And a lot of people would begin to get confused because if you want to give the hydroxyl the lowest number, you end up giving the alkyl halides also a lower number. That's absolutely okay, right? We want to give the hydroxyl a lower number. If everything else gets a lower number because of that, so what, right? We did it correctly. And so we get the name 4-octanol, and on the number 1 and the number 2 position, we have 2 chlorines, meaning so 1,2-dichloro. And if we were to put it all together, we would get the answer A. In number 16, we're asked for the common name. So, if you guys haven't watched my common name videos, this is where it's really interesting. And maybe for some of you, this is where that squiggly line stuff starts to make more sense. This is literally what we're getting, right? This is the larger group that I've been saying with that squiggly line. And so I'm asking you, okay, forget about the bromo. That doesn't really matter. What is the name of this common name? This is isobutyl, right? This is isobutyl. We have four carbons, and they're like, the last one is kind of separated from the rest. And so the name should be isobutyl bromide. In number 17, we're asked to write an IUPAC name. So let's try to find the parent chain. It's probably going to be this one. 1, 2, 3, 4, 5, 6. So I know we have a hexane. And now the biggest problem with this question is, how do we number it? Here's the problem. A lot of people want to start numbering from left to right because they see the bromine. We're like, okay, we have to give it priority. However, I want you to try that, try both ways, and write out all the numbers that you get for the substituents. You'll realize that, okay, yes, if you name from left to right, you'll give the bromine the lowest substituent. But if you write from right to left, you end up giving everything overall a lower substituent. So what's the correct idea? We have to name from right to left. We have to focus on giving everything the lowest number possible. So we end up with this methyl on 2, this methyl on 3, this chlorine on 3, and this bromine on 5. And so what we end up is 3,3-dimethyl. Then we have 3-chloro, and then 5-bromo. I actually made a mistake here. Should actually be 2,3-dimethyl. Apologies. That should be 5-bromo. And so if we were to put it all together, our answer would be C. Question 18 is very similar to concept to one of the questions that I asked earlier. What is the correct IUPAC name for the following compound? I want you to realize that, okay, choosing the parent chain might have a little bit of a difficulty. We know it starts from here, but which direction do we go in? Do we go this side, where we end up with less carbons, or do we go with this side? We end up with more carbons. A lot of people will choose this flat one because they think, okay, we have to give the parent chain with the biggest number of carbons, and that's it. The issue is you're not giving the hydroxyl the priority. You end up the hydroxyl ends up as a substituent of a substituent, right? That's not correct. How are you going to name this methoxide as a substituent? That doesn't make sense, right? And so this is a big mistake that a lot of students make, is that they don't put the hydroxyl on the parent chain. Yes, you want the parent chain as long as possible, but another aspect is that you also want the hydroxyl to be on the parent chain. And so it would actually should be this one. So that's 3, 4, 5, 6. So we know we're going to have hexanol. Obviously, we're going to start putting this on the number 1 position. And then on the number 2 position, we have an ethyl. So 2-ethyl, 1-hexanol. Couple more names to give these last 4 problems. What is the correct IUPAC name for the following compound? Let's try to find the parent chain. 1, 2, 3, 4, 5, 6, 7. And we want to put the hydroxyl on the parent chain. And obviously, it's going to be on a number 1 position, so we can say 1-heptanol. We end up with a methyl on the 3, a methyl on the 5. And so we end up with 3,5-dimethyl. So if we put the whole thing together, we end up with 3,5-dimethyl, 1-heptanol. Question 20, what is the correct IUPAC name? Again, let's try to find the parent chain. We have 1, 2, 3, 4, 5, 6, 7. Okay, and we probably have the hydroxyl on the first position. So parent chain is going to be 1-heptanol. On the number 3 position, we have the fluorine. And the 5 position, we have that methyl. And so we know we have 3-fluoro and then 5-methyl. And so if we were to put it all together, E would be our correct answer. Number 21 is a little bit of common name practice. So we're trying to find the IUPAC name for the common name tert-pentyl alcohol. I want you to realize that pentyl, let's try to draw tert-pentyl. That should be the first step. 1, 2, 3, 4, 5. Okay. And I want you to realize that our rule was that tert-pentyl had the bigger group, or the more important group, attached to this tertiary carbon. And so realize that all that is really, I should draw it like this. It's like that, right? And if we were to now try to find the parent chain, maybe something like this. That's 4 carbons. We have the hydroxyl on the 2, meaning that we have 2-butanol. And then we also have 2-methyl on the 2. So 2-methyl, 2-butanol. In the very last problem, Question 22, write the correct IUPAC name for the following compound. I want you to realize that, okay, this is where finding a parent chain might get tricky. We can probably start from either direction, but which direction do we start in? We know this is going to be part of it, but which direction do we start in? Okay, and maybe we should do this one, right? The issue is that, okay, if we choose this one, we get like what? 2 substituents? But if we go this way, or the other way, this way, we end up with 3 substituents. And so using that same rule that you might have forgotten about from the very first IUPAC video, we need to choose a parent chain that has the most amount of substituents. And so this parent chain should be 1, 2, 3, 4, 5, 6, 7, meaning that we have heptane. Okay, and notice that your hydroxyl is going to get priority with numbering. And so we're going to have 3 heptanol. We have a chloro on the 5, so 5 chloro. And then we have a propyl on the 4. So 4 propyl, 5 chloro, 3 heptanol. And so if we were to put this all together alphabetically, we would end up with 5 chloro, 4 propyl, 3 heptanol. Make sure not to choose this one because it's not in correct alphabetical order. That concludes our worksheet on the naming alkyl halides and alcohols. Again, if you haven't watched this instructional video where you wanted to kind of brush up on some concepts, it's available in the description below. It's only a couple minutes. It's very worth your time. And if you want to see the answer key for this worksheet, it's also in the description below. I'll see you guys in the next video.